So now, in this video, we have a 555 timer wired in monostable mode. So there's one stable state. You can see it right now. The output's low. Blue LED is lit up. It's connected to the positive supply. The long lead, the anode, short lead, the cathode comes to a 1000 ohm resistor right there. So the 555 timer is going to stay like that till I press this button right there. Now it goes high, but then it goes back low. The amount of time that the output is high is set by this capacitor and that resistor right there. So the higher value resistor and capacitor you use, the longer it's going to take to set the output from high there back to low, and lower values will go quicker. And of course you can go higher with one and lower with the other one to balance out the timing and whatnot. But the more higher the values of both the components, the longer it's going to take. Main thing to remember when it comes to the signal that we're given, that's pin 2 right there, closing the switch. It connects to ground when I close the switch. So I didn't point this out in the bistable video that I made last video. We have the gray jumper there going to the negative supply, top of the switch. When I close the switch, top to bottom connects, and then the trigger pin will see ground. Well, the switch is closed. Otherwise, it comes to this resistor and the positive supply. This is called a pull-up resistor. So what it's doing is it's keeping 5 volts at the trigger pin until I close the switch. And we can't just put a jumper there because then it would be a short from the positive supply to the negative supply when I close the switch. So we got a 10K resistor. This is a lot more resistant, so all pin 2 sees is the 5 volts right there while the switch is open. Once we close the switch, it's a direct connection, so all pin 2 sees is ground right there because it's a much lower resistance. Almost no resistance. Practically every little bit of current that goes through that 10K resistor will just go right to ground. Pin 2 will never know they were there. So when it comes to the timing, we got the capacitor and the resistor. What happens is output is low right now, and that's because nothing is happening and the capacitor is more than 2/3 supply voltage, and so it's going to keep the output low right there. We do have the reset pin. It can also set the output low, but that doesn't come into play in this video. We disabled it by going to the positive supply. It's waiting for a low input. As long as it's got more than, I think, like 0.5 volts, it's very close to 0 volts. As long as it's higher than that, it's not doing anything. So we press the button. What happens is the capacitor is discharged right now. Pin 7 is connected to ground. I press the button. Pin 7 stops connecting to ground, and also it was kept the capacitor discharged, and any current that went through the 10K resistor also went to ground right there. So that's something to keep in mind when you pick the value of that capacitor. You don't want to go too low because it's always wasting current, and if you go too low, it may be too much current. But in any case, we press the button and the output goes high. This stops connecting to ground. The capacitor charges while the output is high. The capacitor is charging. They work in the same way. Capacitor sees the positive supply, output is providing positive supply right there. You can use the output to charge the capacitor in many circuits. Keep that in mind. So once it gets to 2/3 supply voltage, that's when pin 6 tells the output to go back low. Another thing to keep in mind is that pin 2, the trigger pin, is the more powerful pin. There you can see I'm holding down the button. Now the output is staying high. So you could also do that if you want. If you want a circuit where if you briefly touch it, this is a way to debounce the circuit. If you're worried that if I hit this, you know, it bounces up and down when you hit it, you know, there's really you don't notice the bounce personally, but electrically it sees, you know, a bunch of up and down bounces. That's a way you can debounce it, so that you know, if you want to hold it down and only get one high output of something while you're holding it, that's one way you can do it. You don't have to worry about the, you know, bunch of little bounces making it bounce back and forth. So pin 2 trigger pin is more powerful than pin 6. Main takeaway right there. Reset pin is more powerful than pin 2. So there's other circuits where you could use the reset pin to force the output low, even though pin 2 wants to set the output high, and so on. Now, well, yeah, we got the capacitor. I was going to mention that. So 100 microfarad, and these capacitors, you know, they got their value written on it, 100 microfarad, and maximum voltage, that's not showing up very good. It looks like 50 volts for this particular one right there. So Higher voltages ones are probably a little bit bigger, but it's not a guarantee, depends on how it's made. So we got that value. It's polarized. There's that gray band over there that goes to the negative side of the power supply. It's also a shorter lead if you don't cut it on all the capacitors I got, at least. So when it comes to lead size, it may not be completely universal, but as far as I know, if you got capacitors, probably if you haven't cut them yet, the longer side is the positive side, and then the shorter lead is towards the negative side right there. Often connecting directly to ground, the most negative part of the circuit. You can't go wrong putting the negative side of the capacitor to the lowest voltage in the circuit. You don't want to put it in backwards, because if you charge the capacitor backwards, especially to a somewhat higher voltage, where you make that more negative, that more positive, it might burst. Hopefully gas will just vent, but it might explode or something. I've seen pictures of these that cause damage. Keep that in mind. Now, we have the output, and you don't get the full positive supply right there, but you get a pretty good connection to ground. So that's when it's high. Instead of 5 volts coming out, it's probably about 3.5 volts. And I make a number of videos where I take those measurements. People don't seem to watch that long, and so I'm not going to take measurements now, but just be aware that you can take that measurement yourself too. Just grab a multimeter, look at the output with this circuit while you are operating it. Makes a pretty good connection to ground right there. So that is one reason why I got a 1000 ohm resistor for the blue LED. Makes a better connection to ground, but also normally I would anyways, because blue LEDs are really bright. You can see power supply says 4 milliamps of current, which is high. Usually it's a couple milliamps of a current. But yeah, as I said before, that 10K resistor is just sending current to ground right now. Well, the capacitor is discharged, so we got those two currents put together. So that's kind of interesting there. But in any case, when I press that, now you can see we got probably 2 or 3 times as much current going through the red LED at least as the blue LED, even though it's only showing like double there. It should be about 2 milliamps of current going through the blue LED. So one thing I can do is just pluck this, and then now we can look at the current. There you can see about 2 milliamps of current right there when the blue LED is not passing any current right there. So the other 2 is the blue LED right there. Something to keep in mind. And when it comes to the red LED, I'll pluck this, hold the button down. So yeah, we saw 2, and now it says like 9, 10 right there. It's kind of interesting. So in any case, I'll put the blue LED back into the circuit. So normally I like to work positive up to a negative down, like you see on the schematic right there. And I thought about maybe wiring this a little bit differently now, but I do this quite often. We got the supply rails at the top of the integrated circuit. Pin 8 is positive supply, and pin 1 is negative supply. So that's always wired up like that. And so the long lead, the anode of the blue LED, is down lower. Hopefully that's not too confusing, that resistor there. It's down lower to that positive supply, up higher to the 1K resistor, which is right now heading towards the more negative supply. And then the red LED, I'll hold the button there. There you can see it's lit up. So we got ground there, so we know the output is high, as close to 5 volts as it can, probably about 3.5 volts. We got the long lead, the anode, up higher to the resistor, the short lead, the cathode, down lower to the jumper that goes to ground. Of course, you got to put it in the right way, or it won't light up. Basic electronic stuff. Hopefully you already know that, but just in case you don't, I'll mention that now. So yeah, the band there is the cathode. If you don't cut them, it's the shorter lead. Somebody mentioned recently they have LEDs where the shorter lead is actually the anode and the longer lead is the cathode. I haven't run across that. I think they might have said they're older components. But in any case, long lead is probably the anode right there. Short lead is probably the cathode. And the cathode, these ones I'm pretty sure have a little shaving on the cathode side. There's a little rim, and probably won't show up on camera too good. But yeah, on the short side, it's probably a little bit flatter right there. So I'm not going to zoom in, just thought I'd mention that. Some of them don't even have that shaving. It's the rim is round all the way around, so be aware of that. So yeah, make sure you put the LEDs in the right way. If the LED is not lit up when it should be lit up, there is a good chance, if everything else looks wired properly, that's another easy mistake, to accidentally put the resistor in a wrong slot on these breadboards or whatever. But yeah, if it's not lit up when it's supposed to be lit up, good chance it is in backwards right there. So yeah, we'll put it back. So that's just one tip. If you turn the power on and the LED's not on when it should be, probably first thing, check that it's backwards. And any case, yeah, I think I covered everything right there. So we're going to end it there. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.